In this video, we will look at some piecewise functions and we will take some examples from the Newton assignment on this topic. So there are two types of questions that you might see in this Newton assignment. You might be asked to evaluate piecewise defined functions like we see here, and then we'll also talk about graphing piecewise defined functions. So when you're asked to evaluate, remember that a piecewise defined function consists of multiple rules, right? But we're only using each of those rules on a specific part of the domain. So for example, this function here, this function rule of f of x equals negative 2x minus 3 is only valid for x less than 0. And then we have another part of the domain from 0 to 1, and then we have another part here. So the first step is actually just to figure out for the given x value, right, which one of those domain restrictions does it satisfy? And so since our x value here is 3, right, we're just checking that against each of these different conditions. So we want to know, is 3 less than 0? That is not true. Does 3 satisfy this inequality? That it's between 0 and 1? That's also not true, right? But it does satisfy that it is greater than 1, right? So the function rule that we should be using here for f of 3 is that last one, right? So now all we have to do is just do that function evaluation. So to find f of 3, we're plugging it into x squared plus 1. So that would be 3 squared plus 1, which gives us 10. Right? And if we use this same function, but a different input value, right? So again, we still have the same three conditions of either we'll have an x that's less than 0, that's between 0 and 1, or that's greater than 1. And in this case, our input is negative 3, which satisfies the first inequality, right? Negative 3 is less than 0. So this time when we plug in our function, our input value, right, we're plugging it into that first rule of negative 2 times our x minus 3. So that gives us 6 minus 3 for an output of 3. Okay, so again, just remember with these function evaluations, we always want to be starting over here to figure out which function rule we're using, and then once we choose, we're only plugging the given x value into that one part of the function. All right, so now let's look at some graphing. So this first example, I know the choices are a little bit small here, but we're going to eliminate a couple of them very quickly. And so the way we can do that, right, again, there's kind of two things we need to be paying attention to here. The function rules themselves, and then these conditions over here, right? And so what I can tell by focusing on this part first is that x equals 1 is the significant domain value, right? That's where we're switching from one piece to another. And so if I look at my choices here, there are only two graphs that are changing from one function rule to another at x equals 1, right? These two right here. The other two, it looks like, are changing at x equals negative 1, right? So I don't want to worry about those. Okay, so already we've eliminated half of our choices. So let me just focus on those two now, right? So now we just have to figure out which of these two graphs matches. And so they're both in agreement as far as, again, this kind of transition point at x equals 1. So now we want to focus our attention on the function rules. Right? And notice both of these are linear functions. So there are a couple ways we can figure this out, right? First of all, I notice that the first one has a function of 2, a slope of 2, whereas the second part has a slope of 1. So what that tells me is that it should be the steeper line first, which would be the graph on the left. But let's actually break it down a little bit further. Let's just focus on one of them. Let's focus on this first piece. So the first piece on the left side of 1 is supposed to have a y-intercept of negative 1, right? Remember, when we have an equation like this, that minus 1 at the end is telling us our y-intercept, and this part here is telling us the slope. And right there, that means I have my choice, right? Because if I focus again on the piece on the left here, this is the one that has a y-intercept of -1 and a slope of up to and to the right 1, right? So it has to be that function, and the other one is out. Right, so here's our winner here. And if we want to be super careful, we can check the second equation as well. The second equation is supposed to have a slope of 1 and a y-intercept of 1. And this one does have a slope of +1. See, it goes up 1 over 1. And if you were to connect that back to the y-axis, it would cross at 1. All right, so let's take a look at one more going in the opposite direction. So here it's giving us the graph and asking us to come up with the piecewise function. So this one is multiple choice, but before I even show the choices, let's just look at these graphs here. And we should really just be thinking about, to start, what type of function is represented by each of these pieces. So when I look at this, I can see that this one is a constant function, right? Because it's just a horizontal line. This one appears to be a linear function, right? And if I go through my different toolkit functions, this last one most closely resembles a square root function. All right, just think of connecting this through. So technically, I guess it could also be a cube root function since we're only looking at part of it, right? But it's definitely going to be some type of root function. Right? So maybe I'll put this part in parentheses. Let's look at our choices now. So if we look at the choices, again, we're looking for something that starts off with a constant, switches to a linear function, and then switches to some type of root function. So right there, we can get rid of 2 of our choices. Right, because those 2 have an absolute value, which is that V-shaped graph for the last part. So we just have to figure out if it's choice 1 or choice 4. And if we look a little more closely, the only thing that's different is in the linear part right here. One of them is a linear function with a slope of 1, and the other is a linear function with a slope of 2. And they both have a y-intercept of 3, so that part matches our graph no matter what. And if we look a little more closely, you can see that the rise over run would give us a slope of 2. So our correct choice has to be this last one here.